body of mass 2 kg, initially at rest, moves under the action of an applied horizontal force of 7 Newton on a table with coefficient of kinetic friction equals to 0.1. Compute the work done by the applied force in 10 seconds. The second part is work done by friction in 10 seconds, work done by the net force on body in 10 seconds, and last part is change in kinetic energy of the body in 10 seconds. So let's see the solution. So first we see the A part. So we have to find the work done by the applied force in 10 seconds. So the mass of body as given is 2 kg. So let m equals to 2 kg. And the horizontal force, let us say it is capital F, is 7 Newton. So we need to find the frictional force. As the surface is rough and coefficient of kinetic friction given to us is 0.1. So coefficient of kinetic friction, that is mu, is equals to 0.1. Therefore, what will be the frictional force on the body? Let us say the frictional force is small f, and it will be equals to mu times normal force. Normal force will be the weight of body, that is m into g. Mu is 0.1, m given is 2 kg, and g we take as 9.8. Therefore F is equals to 1.96 Newton. Therefore net effective force will be equals to the applied force, that is horizontal force, that is capital F, minus the frictional force. Capital F was 7 and small f we calculated as 1.96. Therefore the net force will be 5.04 Newton. So we can find the acceleration of the body, and we know that force is equals to m into a, that is mass into acceleration, and here this force is net force. So acceleration will be F upon m, and F is 5.04 and mass given to us is 2 kg. Therefore acceleration will be 2.52 meter per second. So we can find the distance, that is S will be half, we can use the formula, that is ut plus half ad square. And according to the question, time is t equals to 10 seconds, and initially body is at rest, so u equals to 0. Therefore S will be 0 into 10 plus half into acceleration was 2.52, that is half into 2.52 into t square, that is 10 square. Therefore the distance traveled by the body in 10 seconds under the net horizontal force is 126 meter. So we can find the work done by the applied force. Applied force, that is capital F, equals to 7 Newton, and we know that work done is equals to force dot product of force and displacement. As the force is applied is in this direction, that is horizontal, let us say, and displacement is also in the same direction. Therefore W is equals to Fs cos theta. Here theta will be 0. Therefore W will be Fs. into cos 0, that is 1. And F we calculated, F given to us is 7 and S we calculated as 126. Therefore, work done by the horizontal force is 882 joules. Let us see the B part. We need to find the work done by the friction. We can say this is work done by friction. We need to find this. We know that the work done by the friction will be small f, and this will be small f vector and dot product with displacement vector. And suppose this is body, and friction will act in opposite direction of displacement. Therefore, Wf will be equals to Fs cos theta. Here theta will be 180. Therefore, Wf will be the frictional force we calculated was 1.96 and displacement was 126. And cos 180, which is minus 1. Therefore, the work done by the friction will be minus 246.96 joules. Let us see the third part. We need to find the work done by the net force on the body. So the net force, we can say F effective was capital F minus frictional force, that is small f. Capital F was 7, frictional force was 1.96. In capital and F effective was 5.04. So this was some body. It has been applied with some force, that is capital F. Frictional force is acting in this direction, that is opposite. So the net effective horizontal force will be F effective, and displacement is also in this direction. Therefore, work done by the F effective, work done by this F effective force, as the F effective is acting in the same direction as that of S vector, therefore cos theta here will be 1, because theta is equals to 0 degree, as they both are in same direction. Therefore W will be F effective into S. F effective is 5.04 and S is 126. Therefore work done by the net force is 635.04 joules. In the D part, we need to show change in kinetic energy. We need to find the change in kinetic energy. So we can write it as delta Ke, that is change in kinetic energy in 10 seconds. So initially K initial is half m u square. As u is 0, since u is 0, initially body was at rest, therefore it is K initial is 0. K final is half mv square. Also, according to work energy theorem, according to work energy theorem, changing kinetic energy, that is delta Ke, which is equals to Ke final minus Ke initial, is equals to the net work done. It is W by the net force. Therefore, as Ke initial is 0, Ke final therefore delta Ke, which is equals to Ke final, will be W, and W we calculated as 635.042. Therefore, this is the change in kinetic energy in 10 seconds.